Today, let's talk about bases. Remember, the topic is acids, bases, and salts. Just like the two definitions of acids, bases are also defined differently by two different chemists. According to Vast Arrhenius, a base is simply a substance that dissolves in water to produce hydroxyl ion as the only negative ion. And a good example of a base is sodium hydroxide. So when sodium hydroxide ionizes, it gives sodium ion, which is a positive ion, and hydroxyl ion. So that is the negative ion, and according to Arrhenius, this one is a base. So it's therefore called Arrhenius base. Potassium hydroxide behave in a similar manner. Potassium hydroxide in solution will dissociate to give potassium ion, that is positive, plus hydroxyl ion. So that is the only negative ion, and therefore potassium hydroxide is also an Arrhenius base. Another good example that we can talk about is calcium hydroxide. This ionizes to give calcium ion and 2 hydroxyl ion. So that is also said to be a base, and according to Arrhenius, it dissociates in water to produce hydroxide ion as the only negatively charged ion. And the resulting solution is able to turn red litmus paper blue, as the blue one remains the same, that is remaining blue. Let us look at the definition of a base according to Bronsted-Lowry. But before that, we want to look at some reactions where we have our bases showing the evidence of the production of hydroxyl ion, and that is where we have sodium hydroxide plus hydrochloric acid to form sodium chloride and water. That is ionic equation: hydrogen ion from the acid plus hydroxyl ion from the base, and that gives water, therefore called neutralization reaction. Now, sodium hydroxide is an Arrhenius base, reason being that it dissolves in water to give hydroxyl ion as the only negatively charged ion. Similarly, hydrochloric acid is an Arrhenius acid because it gives hydrogen ion as the only positively charged ion. Another equation can be between copper 2 oxide and sulfuric 6 acid. Or we can use copper 2 hydroxide sulfuric 6 acid, and that gives copper 2 sulfate plus water. Another neutralization reaction where we have hydroxyl ion combining with hydrogen ion to give us water. To balance the equation, we have hydrogen 4, so that should be 4. Then the equation is balanced. Liquid, aqueous, aqueous, solid. Let's look at another definition of a base, and that is according to Bronsted-Lowry. According to Bronsted-Lowry, he defined a base as a proton acceptor. What accepts the proton? What receives that proton? Now, an example, we have ammonia plus water to form ammonium ion plus hydroxyl ion, and such equations are normally said to be reversible. or simply at state of balance. So we have that. That is aqueous gas. Now ammonia, that is hydrogen that is ammonia, plus the proton, and that gives ammonium ion. That is the newly formed bond. Then these are the ones that were existing before. That is ammonium ion, and then it gives that out. So there is no need of including this because we are having just ammonia gas and hydrogen ion. Now, this ammonia has a lone pair of electron. It is able to accept the hydrogen ion to form ammonium ion. So this is what we call Bronsted-Lowry base. It accepts the proton. So water is the Bronsted-Lowry acid and ammonia is the Bronsted-Lowry base. Another example, methylamine. We can have CH3NH2 reacting with water, and that gives CH3NH3 with the charge plus hydroxyl ion. Now, this one is able to accept a proton that is from water, and that forms an extra hydrogen there, meaning it is the proton acceptor, and therefore called Bronsted-Lowry base. Simply a proton acceptor. So that is all about the two definitions of a base.